See, ma'am. Now, previously we have taken two conductors. This is one conductor, this is another conductor, this is I1 current, this is I2 current. Then force per unit length is equals to mu naught I1 I2 divided by 2 pi into R. This was the equation which we have derived. No? Now, instead of current carrying conductors, if I consider only charges, point charges, this is one charge, this is another charge moving with velocities v1, v2, then force existing between them is, this is the equation. Clear, ma? So mu naught by 4 pi q1 q2 v1 v2 divided by r square. Are you able to understand? Right. See, ma. So this is a straight conductor, ma, which is carrying a current of 20 amperes. And this is a loop. This is a rectangular shaped loop. One length is 6 centimeter, another length is 15 centimeter. And it is carrying a current of 16 amperes in this orientation. Okay. Then I want to find out on this loop how much force will be present. How can I do it? How much force will be acting on this loop? Or what is the force existing between this current carrying conductor and this loop? How can I do it? So let us do one thing. Let us name this loop as A, B, C, D. Okay. So directly we cannot do the calculation because we did not find out force experience for this kind of structure. No? We have calculated force experience between two conductors only if they are straight conductors or if charges if they are moving. But here 4 wires are there and here only 1 wire is there. Are you able to understand? So what I will do is, first I will take this wire and this wire. Or you can take any wire. In this wire, what is the direction of current? This is the direction of current. No? Are you able to understand? No? So therefore, this is the current carrying conductor. It is carrying 20 amperes of current. And I will take only length AB. AB. Are you able to understand? No? Now, because of this current here on the wire, can you say what is the direction of magnetic field? Because of this wire, magnetic field because of this wire will be in which direction on this wire? Magnetic field is perpendicular and inside the board. So here I can say B dash is perpendicular and inside. Okay, ma? So if B dash is perpendicular and inside, then this current carrying conductor will experience force in which direction? B dash is inside. Current is in this direction. Magnetic field will experience force in which direction? Yes. So F is equals to, F dash is equals to I into L dash cross B dash, no? Force experienced by current carrying conductor when it is placed in magnetic field. So L dash, this is the direction of current, no? L dash. B dash is inside. Force is in which direction? Upward force. This is the force experienced. Clear? Let us take CD. Okay, ma? So CD. So this is the wire. CD is like this and current is in this direction, no? Ma? Clear, no? So because current direction has reversed, previously current was in this direction, in AB. Now in CD current is in opposite direction. So it will experience force in which direction? Exactly in opposite direction. So this is the direction of force experienced. And magnitude wise it will be same, no? Because length of the conductor is same, current is same, distance is same, currents are same, everything is same. So this force and this force, they are equal. It means on AB force is acting in this direction and on CD force is acting exactly in opposite direction. So what can I say? These two forces, they will get cancelled. Are you able to understand, ma? So therefore, forces on AB and CD gets cancelled. These two forces will get cancelled. Are you able to understand? Now let us take loop CA. Okay, ma? So current is in this direction and in CA also current is in the same direction. Then already we have studied force of attraction will be present, no? Let us call it as F1. If currents are in same direction, what kind of force? Attractive force. And what is the value? So force per unit length. Force per unit length of the wire is equals to mu naught I1 I2 divided by 2 pi into R. This is the equation. Are you able to understand, ma? So force per unit length, what is the length of this wire? 15 centimeter. So take it on the other side. So F1 is equals to mu naught multiplied by, what are the magnitudes of current ma? One is 20 amperes and the second one is, here what is the current? 16 amperes. Multiplied by 2 pi into, now what is the distance between these two wires? 4 centimeter. So 4. And here length is also in centimeters, no? Length is how much? Length is 15 centimeter multiplied by 15. You need not convert into meters because conversion units will get cancelled, no? Okay, so this is the force experienced by AC. Now I want to calculate force experienced by BC. So this is BC. Okay, ma? So wire is in this direction. This is 20 amperes of current. And here we have BD, no? BD na, BC na? BD. Okay, ma? So this is B, this is D. So now do the calculation. So F2 is equals to mu naught. Strength of current is same number, 20 into 16 multiplied by length is also same 15 divided by 2 pi into. Now what is the distance between this wire and this wire? 4 plus 6, 10 centimeter. So multiplied by 10. This is the force on second wire. Now this wire will experience force in which direction? Opposite direction. It will experience repulsive force, F2. So this one I am calling F1, this is F2. Now F1 is bigger or F2 is bigger? Which one is bigger? Huh? F1. How can you say? Denominator is smaller, no? Here denominator is 4, here denominator is 10. So definitely I can say that F2 is big, F1 is bigger than F2. So F1 is attraction or repulsion? Huh? Attraction. So attractive force is greater than repulsive force. So net force will be attraction or repulsion? Attraction. That is our answer. Clear, Rama? So therefore, net attraction is how much? This is F1 minus F2. Now I am not doing this calculation. Do it. That is our answer. Okay? Sima. So here, this is an inclined plane, ma, whose angle of inclination is 30 degrees. This is a smooth surface. And on this smooth surface, we are placing a current carrying wire. It means how current, if this is the current carrying wire is placed like this. Then you can see only this circle, no? So wire is arranged like this. Or you can say, if this is the inclined plane, okay, ma? Wire is arranged like this. This is the arrangement of the wire. Okay? Now what is the direction of Subarao? So now, what is the direction of magnetic field? Magnetic field is downwards and it is present in the plane of the board. So this is the direction of B dash. Are you able to understand, ma? Now the question is, what should be the amount of current that should pass in this conductor such that this wire remains to be in rest position? Okay, ma? See, ma, if there is no magnetic field and if there is no current, this wire starts rolling downwards, no? Wire falls down and it reaches to the bottom of this inclined plane. But I want wire to be present there only. So how much current I have to pass? And current I should pass in which direction? Out of the board or inside the board? It means that if I say this is the conductor and if I draw a dot here, then it means that current is coming out of the board. Clear, no? And if this is the conductor, if I draw a cross, it represents current is entering into the board, entering into the conductor. So first of all, direction I have to find out. Then I have to find out strength of current. How much current should be passed so that conductor doesn't slide downwards. Okay? Anybody? First of all, say the orientation of current. Current is entering into the conductor or current is coming out of the conductor. First of all, try to say that. ఏంద్ర అట్ట చూస్తున్నారు, ఎలా చెప్తారు? కరో మీరు మాలేసారు. సీమా. So already explained the question, no? See here, First of all, we will find the orientation of current. See here, consider for example, current is entering into the board. Conductor is like this, clear ma? Current is entering the conductor. Are you able to understand? And consider magnetic field is already given, it is in downwards direction. So this current carrying conductor will experience force in which direction? F is equals to I into L dash cross B dash. Clear, no? Length is in this direction, no? Okay, ma? Length of the conductor is in which direction? This is the length of the conductor. Magnetic field is in which direction? Downwards direction. So L dash cross B dash. This is the direction of thumb, no? So it means this conductor will experience force in this direction. Okay? If it experiences force in this direction, what this force is doing? It is pulling this rod or pulling this wire down the plane. Ante inka easy vastundi kindiki. Are you able to understand me? If this is the orientation of current, this force will pull this conductor downwards. So it means this is not my direction of current. Current should be in which direction? Current should be in this direction. Or I will do one thing, this is wrong. So here we will take one more direction of current. Clear, ma? So this is the conductor and consider current is coming out of the board. This is what? Current entering inside, no? Sorry, this is cross. Sorry. This is cross. Okay. So this direction is not wrong, not correct. Now, let us consider current is coming out of the board. Okay? If current is coming out of the board, this is the direction of current. So how I should place my right hand? This. But magnetic field is downwards. Clear, no? So L dash cross B dash. Now what is the direction of thumb? So thumb is acting in this direction. It means this is the direction of force. Are you able to understand? So therefore, current is not current is not entering the board, current is coming out of the board. This orientation is correct. Are you able to understand? Because if this is the force, this force always I can split into two components, no ma? So what is the angle theta here? 30 degrees. So this force I can split into two components. Are you able to understand? So this is F cos theta. If this is 30, this is also 30. So F cos 30, F sin 30. Are you able to understand? Now see what is the direction of F cos theta. F cos theta is present in this direction. Are you able to understand? So this force is responsible to pull the rod above the plane. Okay? And rod will have its own weight also, no? Weight of the rod will be how much? Mg. Split this mg into two components. If this is 30, this is also 30. So this is mg sin 30 and this is mg cos 30. Clear, no? So what is mg sin 30 doing? Mg sin 30 is pulling the rod downwards. Are you able to understand? So this mg sin 30 should be balanced by F cos theta. Then the rod will be in rest position. Okay? So are you able to understand, ma? So therefore, mg sin theta and F cos theta, when they are balancing with each other, then I can say this rod will be in rest position without sliding down or without moving in upward direction. Okay? So therefore, equate both of them. So mg sin 30 should balance F cos 30. Okay, ma? And what is the equation of force? F is equal to ILB sin 90. Why sin 90? Length is like this, field is like this. Angle is 90 only, no? So therefore, F value will be how much? It is ILB. So substitute here. So therefore, mg sin 30 is equals to F cos 30, no? F is ILB sin 90 multiplied by cos 30. So I want only I value only, no? Strength of the current I want to calculate. So therefore, I is equals to mg sin 30 divided by L into B into sin 90 value is 1 multiplied by cos 30. So I is equals to mg tan 30 divided by L into B. Okay? So mass of the wire, length of the wire are not given. But mu value is given. What is mu? Mu is called mass per unit length of the wire. What is mu? Mass per unit length. Friction already 0, it is given now. So this is called linear density of the rod. Units student akkada kg per meter. It means per unit length of the rod, how much mass is present. So mass per unit length is 0.30. So substitute here. So I is equals to m by L multiplied by G value is 10, tan 30 value is 1 by root 3 divided by B. What is the strength of magnetic field? 0.15. So mass per unit length is 0.30 multiplied by 10 multiplied by 1 by root 3 divided by 0.15. So do this calculation. That is the strength of current required so that a rod remains to be at rest position.